One day off, right? Really have to come in here like.
You know, with a course, I spend the course 5 minutes in the car.
Let me remind you guys,
I spend the 5 minutes in the car again. I mean, this will give you a chance to like.
right, we're doing section 2.1.
Yeah, shut up.
Section 2.1.
Last time I gave you 7.5.
Okay, right, the most important section of the course. Right. Be good to know. So this was from last time. We're gonna finish this up. It is a pretty big section. Right, so one thing is we're trying to get the slope of a curve. That's what tells us how fast the curve is changing. Right, at a certain P, located at a certain A value. And we're saying that the tangent line gives us the slope. Right, so the tangent, the slope of the tangent line. Tangent line. Limit as h goes to 0, and it's rise over run. So it's the change in y, f of a plus h minus f of a, divided by the change in x, right? And then x changes by h. Okay, that's the slope of the tangent line. We also had secant lines. We also had a secant line, and we had the slope of a secant line. So if Q is located at A plus H, so the secant line P to Q, right? What's the slope of a secant line? Well, it's just you have 2 points, rise over run between 2 points. The slope of a secant line, F of A plus H minus f of a divided by h. So it's just rise over run between 2 points, P and Q. That's the difference. So we have tangent line, secant line, both are slopes. One tells us exactly what's happening at P. Let's see. Okay, Sean?
The h always gonna be 0 because every example we had is always been a 0.
Yeah, that's the definition. Yeah, the definition is we're bringing P and Q close together. So the definition is h is going to 0. We're bringing Q close together. So a lot of your homework is problems where you guys have secants. So the thing is, the tangent line, let's call it the tangent slope, is approximately equal to the slope of the secant line when Q is next to P. I should say is close to P. Okay. So some of your homework assignments, they want you to approximate the slope. So the secant line, just take the slope of the line between 2 points. That'll give you a nice little approximation of the tangent slope. Yeah, Matthew?
I have a question about the homework. Do you think you could go over one of the questions?
Yeah, I want to go over a little bit more on what you need for the homework, and then we'll go over it. Yeah, just so you guys have all of it. That's the slope of a tangent line. And in terms of just the etymology, Sapael asked last time, right, where is the word secant? Why is it called secant? But I said it comes from Latin. That's true. I said it means two. It does not mean two. I want to correct that. Secant comes from Latin, means cut. It cuts the graph into two or more points. So secant is cutting. So it's a line that's cutting the graph. Latin word. And if we're dealing with a circle, it will be two. It will be 2 points. A general graph not. So it's coming from that Latin word. And tangent is coming from the Latin word means touch. The touch. So we think of it as when it's curvy or at least a circle, the tangent line is just barely touching the curve. Just kind of touching it and grazing it. The real definition of a tangent line, you don't want to know. Math analysis books, real definition would be basically the best line that there is to approximate the function. So you need to use some mathematical verbiage to make it concrete. That's what it would be. Okay, but intuitively, the secant line is cutting in the graph into 2 points. Tangent line is just kind of touching it in this picture. And we had velocity, just so you guys could compare it. So velocity is when you have a function that's giving you position. Position. Okay. And we had the instantaneous velocity was limit as h goes to 0, f of a plus h minus f of a divided by h. Okay, do you guys see it? Do you guys notice something? You guys notice a similarity between the slope of a tangent line and velocity? Right? No. What do you notice? Yeah. The same exact formula. That's right. The two ways of representing the same thing. That the slope of a tangent line, if your function happens to be dealing with position, is actually giving you your velocity. Because rise over run in physics is going to be change in position over change in time, which is velocity. And this is instantaneous velocity. So what's the slope of a secant line if we're dealing with a function that's giving you position? Well, that's the average velocity. The average from A to B, right, it's going to be f of B minus f of A divided by B minus A. Okay. And if you want, if you set H equal to B minus A, it's just a little notation change. If you get H equals B minus A, sure enough, you get the same exact formula for the slope of a secant line. Okay. All right, so this is what we want to get out of it. We want to get out this. We have a secant slope and a tangent slope, but when we're dealing with the position function, they actually are telling us useful things in physics. They're telling us average velocity, how fast the car was going in a certain time interval, and the instantaneous velocity, which is what your speedometer reads at time A, exactly at time A. Okay, any questions about these? Okay, so I'm gonna keep these here for a little bit. So you could stare at them for an extra second longer. Okay, just realize that it's the exact same formula. Okay, it's the physical interpretation of the slope of a curve. Okay. Okay. So let's do an example. All right, so example is okay. Ball is dropped from a tower. Distance fallen is f of t equal 4.9 t squared. 4.9 t squared. Okay. This just comes from acceleration, the force of gravity, right? Ball very high up starts accelerating. So that means as time goes on, it really starts speeding up. It's accelerating. It falls quite a bit. Falls quite a bit. So part A, so find average velocity from e equals 5 to t equals 5.1. I think maybe they're doing this in meters. Okay, and t is number of, let's say, seconds. Average velocity. So the average from 5 to 5.1, right? It's the slope of a secant line, right? It's just the slope between 2 points. F of 5.1 minus f of 5 divided by what? What's the change in t? Rise over run?
5.1 minus
0.1.
Good. So 5.1 minus 5, so it's 0.1. Okay. So, do you guys see how to get the average? So anything on the WebAssign where they ask you the average velocity from 2 times, that's all you have to do. Just get the slope of those 2 points. So you rise over run. So you'll have a couple average velocity questions on the WebAssign. So just use this formula for the slope. That's it. That's how you'll answer them. Okay. So it's 4.9 times 5.1 squared minus 4.9 times 5 squared divided by 0.1. And let's see, this will end up being 49.49. What are the units? What are we going to get for average velocity? What kind of units? Meters per second. How else could we tell? Well, it's a fraction. The fraction, the numerator is F is measured in, Y values are measured in meters. The denominator, the T values are measured in seconds. So we know it's meters per second. We know it's meters per second. So part B, find, how about the instantaneous velocity at t equals 5. So that is, find v of 5, find the velocity at 5. And find the velocity at 5. Okay. So the way you guys do this, every time you'll start with the same formula, limit as h goes to 0. It's always h goes to 0. Right? The a value here is 5, so 5 plus h minus f of 5. So that's the rise. And the run here is always h. Right? You're always going to start with this formula. Slope formula. You're going to take a limit. Okay, so I'll give you guys a moment, try to do this, right? Here's your function. So most of what you have to do is pre-calculus, plug in 5 plus h for t. Plug in 5 for t. And you'll have a 0/0 limit, so you'll need to simplify it with algebra. Okay. Try to do it. Right, it's limit as h goes to 0. 5 plus h, I'll start you guys off. 4.9, 5 plus h squared. I'm plugging in the number 5 plus h minus. Okay. See how far you guys can get. Okay. Use this function.
Yes.
Uzaktan. Yes, sir.
Okay, so this limit is 0/0. Limit as h goes to 0. What kind of algebra do I have to do to simplify it? Matthew?
You got a foil?
You have to FOIL it, right? This is the foiling one. So I'll factor out the 4.9 to make it easier. So I have 25 plus 10h, right? Good. Plus h squared. And then minus what?
25.
Minus 25.
4.
All divided by h. Okay. If things go well, you'll cancel the h.
Yeah.
If they don't, you can't cancel the h.
Yeah.
Then you made an algebra error, so you have to go back and fix it. Don't propagate your algebra errors and pretend like you're canceling something that shouldn't be canceled. Yeah, Matthew.
Wouldn't it be good to have 1h left? So you can plug 0 in?
I mean, it doesn't matter, as long as you're just not dividing by 0. What's left won't matter. You just don't want to divide by 0.
Yeah.
Yeah, so as long as the h in the denominator goes away, you did the algebra right. If it won't go away, you have to go back and check your algebra. So the 25s cancel. And we're left with limit as h goes to 0. 4.9 times 10h plus h squared over h. Now what do I do? How do I go further? Listen, right, from the numerator, right? Good. Alyssa's saying you have to factor out an h. We don't do what some people are gonna do on the exam is they're like, oh, I have an h here and an h there, let's just cross them. right? I know you're out there. I know you're out there. Anyways. Limit as h goes to 0. If we do what Lissa says, is we're gonna factor out an h. 10 plus h divided by h. Good. Multiplication. Now we could cancel. H goes to 0. Yeah, h goes to 0. So we can plug in 0 finally. So 4.9 times 10. 49. What's the units? Meters per second. If I didn't know it was a velocity problem, I would just say, oh, the numerator is blah. Denominator is some other blah. So the units is blah over some other blah. That's what it is. But here it's meters per second. Now notice this was like the tangent slope, and part A was the secant slope. You notice something interesting about them, the two numbers? They're very close, right? That's the whole idea, is that the secant slope will be very close to the tangent slope, always, as long as the two numbers are close. So 5 and 5.1 are close to each other, right? So the average velocity is going to be very similar to the instantaneous velocity. So I'll even write that down. So V of 5 is going to be close to V average. No, 5 and let's say some other number B, if B is close to 5. You can approximate the actual velocity, right? Just by taking an average. Right? They're very close to each other. Now, the WebAssign, what they want you to do, the WebAssign actually wants you to take two averages. I'll show you why in a second, but another way that we could approximate it is we could approximate like V average from 5 to 5.1. And we could also approximate it by V average, you know, of 2 other times. Let's say before 5, like 4.9 to 5. And the WebAssign on some problems, they want you to take the average of the average, right? They want you to take these two secant slopes and then average them. And that'll give you also a good approximation. Okay, why would they do that? Why do they want you to do all this work? Well, actually, you could prove that this approximation is just a lot better than this one. It causes a proof, but when we approximate instantaneous velocity, this approximation happens to be way better. Okay. So yeah, on your WebAssign, guys, when they want you to do something like this, so V average 5.1, notice we already did that one, that's 449.49, right? They want you to take another approximation, let's say 4.9 to 5. So V average 4.9 to 5 equals, how do I compute it? What do I have to do?
F of percentage.
Right, F of
4.9, sorry, F of 4.9
you could do 4.9 first. That's fine. Just be consistent. Minus
minus F of 5,
F of 5. Good. But then what's the denominator?
9 and 5.
Okay, 4.9 minus 5. That'll give you another average. So F of 4.9. So you get 4.9 times 4.9 squared minus 4.95 squared divided by negative 0.1. You know, anyone have a calculator that want to tell us this decimal? So I could write something pretty.
2401 for the square root of 4.9
Uh,
times
Yeah,
On
the
your
final answer after all this decimal. Like on an exam, I'll just accept this because I don't care about it, but just for the sake of making a point. Let's see.
38.51.
Yeah, Matthew, you got an answer?
48.51.
Okay, as long as it's close to 49, I'll buy it. 48.51 meters per second. Again, very close to the instantaneous that we're supposed to. So just watch out for these WebAssign problems. Is that you guys might get 49.49, you might get 48.51, and WebAssign keeps marking it wrong. Look at the direction. Sometimes they want you to average the two secant slopes. So another approximation, so V5 is gonna, I can average the two, 49.49 plus 48.51 divided by 2. And we get what do we get? 49 exact. Whoa. Okay, I normally won't be exact, but guess we got a good problem where it's exact. Okay, the idea is that doing this, it wasn't just this problem, it's just always a better approximation. So computer algorithms, when they try to approximate velocities, you don't want to do a complicated limit formula. So when they approximate velocities like this, they'll take this kind of an average, which will give you a really, really good approximation. It depends what it asks for. Like usually it needs to be very specific. It'll say approximated with an average. I think the WebAssign phrases it, take two averages, with the time before and after, and then average those two. So it'll be very specific what it wants. Okay, I'll even open up the WebAssign just so you guys can see. Maybe I'll open it now so that it's clear. Let's see what I mean, guys. 2.1. Okay, yeah, like see this problem. You have a tank which drains from the bottom in half an hour. The values in the table show the volume of water remaining in the tank at each time. Okay, so like part A, it's asking you if the point 15,490 on the graph, find the slope of the secant line when Q is the point on the graph with 5, 10, 20, 25, 30. So for that, that's just a regular average. So you're going to take point P, which is 1549, and then you're going to take different points Q, like if T is equal to 5. So this point is Q if T is equal to 5. So you have point Q and you have point P, and you have to get the secant slope, and that'll give you the average. That's the slope of the secant line. T equal 10. So that means your point Q is this one right here. You guys see my mouse cursor? And then point P is the one that they tell you. And then again, that'll give you another average. Just take the slope of a line between those 2 points. And look what it says. Estimate the slope of the tangent line by averaging the slope of the two adjacent secant lines. That's what we just did. So the two adjacent ones is you're going to take this point P, 15,490, and you're going to get the secant slope with the point next to it. Rise over run with the point next to it. Then you're going to take this point P, and you're going to take the other adjacent, the adjacent point, and you're going to get the average, the secant slope with the point next to it, right? So you'll get two secant slopes, and you'll average the two. You'll add them both up, divide by 2, Does that make sense what they want? Okay, so, yeah, so this one, you don't have to do limits, you don't have to do anything. You just compute secant slopes between those points. And that approximates the tangent slope. Yeah, does that make sense what to do for that problem? That's for like number one, and then number two is what we did last time, so just a bunch of secant slopes with this function. I think in class I did the function x squared. Just keep in mind they're asking for 6 decimal places, so you know, be careful with your rounding. So use a calculator and don't round until the end and get 6 decimal places. If it still marks it wrong, it's probably an algebra error.
You show us how to do like one or two of them.
Yeah, you follow. So I did this example, except my function was x squared.
Yeah. But it made it a lot easier, but I was confused with the fraction.
Yeah, so the fraction means you're plugging it into this function. I'll show you guys in a second. So for this example, yeah, so right here, exact same thing. So the point Q, let's say for the first one is 5.9, right? And you have to plug it into the function. Now your function is different, so you have to plug it in. So 5 minus 5.9. Yeah, Matt, does that make sense? You see how I got point Q? So the only difference between this problem and what I did in class is I had x squared, so it would have been 5.9 squared, but you have to use this function they give you. So then the secant slope, MPQ, is they give you the point P is 6, -2. So -2 minus, so rise over run, 2 over 5 minus 5.9. And then the run is 6 minus 5.9, so it's still just rise over run. You just follow that example I did in class, so yeah. Just get 6 decimal places. But Matthew, does that answer it?
Yeah.
Okay. Just do that for a bunch of them. Yeah, and see, number 3 is average velocity. So I just did a problem like number 3, getting a whole bunch of average velocities.
Professor, if you don't mind, can you go up to 2 again?
This
Where you
one?
get the -2 from? On the piece of paper you wrote?
Oh, that's the
Oh.
point they give you, 6, -2.
Another number, that's why I got confused.
Yeah. So I use -2 because the point they give is -2. If you have a different number, you'll just do rise over run with your numbers.
Got it, thank you.
But in the end, you're just doing rise over run. Okay. Okay, part C is a little bit tricky for this problem. It's how fast is ball traveling when it hits the ground. So in this example, so they throw a ball that's free fall, and I think they said the building was 450 meters. So it's falling, and they want to know how fast is it traveling? What's the speed of the ball when it hits the ground? Okay. So the function is still 4.9 t squared. Um, so what they're asking you to do is find V of T naught for T naught time it hits the ground. But when does it hit the ground? How would I figure out when it hits the ground? That I don't have to do any like limits. I just have to know when it hits the ground.
It says 0.
What is it?
It says 0.
Oh, you mean like the velocity? So the velocity won't be 0. You're probably thinking if you throw a ball up. If you throw a ball up before it falls down, the tippy top, the velocity will be 0 before it falls. But if the ball is falling down to the ground, velocity when it hits the ground is not going to be 0. It's going to be really fast. It's going to be really fast. Yeah. When f of t, so f of t is the very close. F is actually the distance that it travels. So we're not going to set it equal to 0. We're going to set it equal to when it hits the ground. How far has it traveled? Right. The distance, negative 450. Distance is 450. 450. Yeah, Jackie.
So is this like the longer route to deriving it for velocity?
What is it?
It's the longer route to actually deriving it for velocity.
Well, it depends what you mean by the longer route. The thing is, they're asking us what is the velocity. So we do have a formula for velocity. We just don't know which time to compute it at. Yeah, so we have our velocity formula. Here it is. It's the slope of a tangent line. But we don't know what A is. Like velocity at which time? They're saying, well, the A value, you want to use the formula, go ahead, but tell me which time. So we have to figure out which time that they're asking you for. And that's the time that it hits the ground. So, but which time is that? Right? Which time is it hitting the ground? So we have to set 4.9 t squared. We'd have to set it equal to 450. Right? Then we're going to know what time that it hits the ground. So then t is equal to the square root of 450 divided by 4.9. Now, normally it would be a plus or minus square root, but I didn't put a negative. Why not?
Because time cannot be missed.
It's time, it's positive, so I just dropped the minus sign. But okay. What does that end up being? Let's see, it's about 9.6 seconds. Right. So after 9.6 seconds, the ball is going to hit the ground. And we want to know how fast is it going? How fast is it going at that time? So we want V of 9.6, right? That's the time that it hits the ground. We want to know the exact moment, right? We're just curious. How fast is it going? Okay, then its limit as h goes to 0, right? F of 9.6 plus h minus f of 9.6, all divided by h. Right. Yeah, Jackie, does this answer your question? So we're always using this formula, but we needed to know which a value to pick. We needed, yeah, 9.6. Okay, good. Other questions? Yeah.
Is this like the formula for instantaneous velocity?
That's right. It's the formula for instantaneous velocity. So right here. Good. How do you know? They have to tell you. They have to tell you. How do you know when to use average versus instantaneous? Is they have to tell you, tell me the average from here to here. It's instantaneous. They'll have to say, tell me the velocity at this time. So average will be between 2 times. Instantaneous will be at 1 time. Yeah, good, good. So they have to really specify it. Let's see, Matthew. What is it? The 3 on the web assign?
I'm in 5 on the website.
5 on the web assign? Yeah. Okay. So for this one, limit as h goes to 0, it'll be 4.9, 9.6 plus h squared minus 4.9, 9.6 divided by h. Okay, and again, you guys FOIL this out exactly like we did before, 9.6 squared. Okay, and then you'll get 4.9 times 2 times 9.6 meters per second. So I'll just leave this for you to do this. So the algebra is exactly the same thing as part B that we did. The only thing that was different is we had the number 5, and you're going to do the exact same thing that we did before, but now it's the number 9.6. Okay. It feels kind of redundant, doesn't it? Right? Like we already did this with the number 5, and now we have to do this with the number 9.6. And then what if they asked you to do it with the number 9.3, 9.2, 9.1, 9, right? Do we really have to do this for every single number? No, we'll see. We could just do this once. We could just do this algebra once. We'll be able to get velocity at any time. Do that a little bit later. Okay, questions on this example? Okay. Okay, let's see. Matthew, you were asking for a WebAssign problem? Is that what it is?
Did you?
Number 5 you're asking for? Part A, B, C, or just everything? What is it?
Yeah.
No, oh, Matthew I. Part A, yeah, Matthew I. We got 2 Matthews. Is there a third? No. 2 Matthews. All right, T and I. Got T and I. Okay. Part A, find the slope of the tangent line at the point 1 comma 7. So you have to use the formula, right? So your function here is 8x minus x squared, and they want the slope of the tangent line. So what's the a value that they're giving you? They have to give it to you. What x value do they want the tangent line for?
1.
1. So your a value is 1. They want your slope at 1. So it's going to be limit as h goes to 0. F of 1 plus h minus f of 1 divided by h. Okay. But it's a good question. This is where we see a lot of algebra errors get done. Algebra errors in the making come from problems like this. Okay. Can someone help the class? How do I plug in 1 plus h? What should I write down when I plug in 1 plus h? H times 1 plus h
Minus.
minus
Yeah.
1 plus h squared on the h or parentheses? Parentheses squared, like that. And then minus, when you guys do the 1, yeah, minus
7.
8 minus 1 is 7. Okay, so very important. All the errors come here. Where students can't plug in 1 plus h. Weird things, yeah. Oh, I plugged in 1. See, in the formula for the slope, it's f of 1 here. So 8 times 1 minus 1. 8 times 1 minus 1. Yeah, so f of 1 is 8 times 1 minus 1 squared, which is 7, divided by h. Okay, see if you guys could do this. Write this out, right? How will you know that the algebra is correct? Is the h will cancel. The h in the denominator, right? Good little exercise. See if you could do this without an algebra error. Okay. H goes to 0. Okay, so just be very careful with your algebra. It's 8 plus 8h, and then minus the quantity, 1 plus 2h plus h squared minus 7. All divided by? Okay, what could I simplify?
8 and 7, so it becomes just 1.
Right, look, I have minus 1 here and minus 7. Right, those cancel. So what am I left with? Limit as h goes to 0. I have 8h minus 2h minus h squared divided by h. Okay. You guys able to get that? If not, check your algebra.
H, open parenthesis, 8 minus 2.
Yeah, so I could factor out an h in the numerator. If I factor out an h, what do I get?
Yeah, 6 minus H.
6 minus
H.
h divided by
H.
h. What happens?
Cancel the H's.
Right? What'll always happen? And now what?
Just 6.
You plug in
Plug in 0.
h equals 0, right? Plug in h equals 0, right? That's the slope. Slope is 6. Part B, they always want you to get the equation of a tangent line. Now the point they gave you, it's 1 comma 7 is the point. And we need y minus y naught is equal to m times x minus x naught. So you'll see all these problems. They'll ask you, tell me the actual line. What do I put for y naught?
7.
7. What do I put for the m, the slope? 6. Right? The 6. Did everyone say 6?
Yeah.
right? That's the whole point. We were spending all this work to get the slope, and then x naught is 1. So y minus 7 is equal to 6 times x minus 1. Yeah. See. Yeah, so Matthew, that answer your question like that? Okay.
네, 시간. 아니, 영어 중에 봐라. Isso.
Okay, we have a slope of a tangent line, section 2.1, right? We have velocity formula, right? Okay, we need one other key definition. So this is section 2.7. You have a function f of x, right? We need one more definition. So the is a fancy definition. So the derivative, something called the derivative of f of x at a number a denoted f hash a. So this little hash mark is the notation that's called the derivative. So sometimes we'll say f prime of a. So this little hash mark f prime of a, right? So the derivative, and look what it is. F prime of a is this. Here's the definition. It's f of a plus h. Now minus f of a divided by h, and the limit as h goes to 0. That's the definition of a derivative. This crazy, fancy term, we have to figure out where it comes from. Derivative, that's the definition. Does anyone see anything familiar about this crazy definition?
Is it just derived or just to do the whole process of the function a plus h?
Yeah, this is the definition. Yeah, this is the definition of the derivative, right? So we have to do this whole numerator denominator thing. Yeah, so I mean, eventually we'll get shortcuts. We'll get shortcuts. There are shortcuts, but that is the definition, right? That is the definition, right? Circle it. Right? Does anyone see, a pattern here?
The same thing again.
It's the exact same formula. Slope of a tangent line, velocity, derivative, right? They're all representing the same thing. They're all representing the same thing, just in different contexts. It is giving us slope. It is giving us the slope of a tangent line. It is. Okay. What does derivative mean? Well, it just comes from English. Derivative means comes from something. It's derived, meaning comes from something. What does it come from? It comes from f of x. It comes from the function. So derivative means is we're getting this new thing, which is the slope of this tangent line, and it's coming from f of x. It's coming from the actual function. That's what it is, right? Right, and the rest of the semester, we're going to be trying to understand, that's what we're going to be doing this whole semester, is why this, the derivative, is actually more useful than the function. It gives us more information than the function itself. Okay. We'll have to see that as we go along. But I'll do some examples. Any questions on this? Okay, do you guys see that to calculate the derivative, you're going to be doing exactly what we've been doing for this class and last class. We're just going to be doing this formula. Okay. All right, so example. F of x is equal to x squared minus 8x plus 9. All right, find f prime of 2 using the definition. Okay, so for all these problems, you have to use the definition.
Can we just plug in two? Can we just plug in two?
Well, plug in 2 will tell us f of 2, but this is f prime. This is f prime. This is the derivative at 2.
Negative four?
We'll see. We'll keep that in suspense. Okay. Yeah, but those of you that have taken calc and that want to use one of the shortcuts, 0 credit. It'll say on the exam, 0 credit. 0, big, fat, 0, no points for doing it. Okay. Why? Because the definition, we're learning the definition, and in practice, when you do computer algorithms for derivatives, they all come from the definition. You can't use shortcuts for the computer algorithms. They all use this definition that we wrote down with the limit. Right? Yeah, Jackie.
Saying for the test, we have to do the full equation.
Yeah, the formula that I wrote down, the definition of the derivative. Yeah. It's going to be this, right? This is the formula for the derivative, right? It'll say big fat 0 for doing anything else, right? Because this is the formula that you need. If anyone does computer science here, and you have to program it, it's all going to come from here, right? Shortcuts are, you can't really program those. Yeah. Right. Okay, so it's f prime of 2. It's always the limit as h goes to 0. You're using the shortcut, yeah. Yes, be careful. Doing the shortcut will get you 0 credit on the exam. I know you could do it in a second using the shortcuts for students that have taken this course.
Yeah, this is for the slow. I was wondering if they'll still use it for slow.
It was cool.
Yeah, so watch out, guys. Watch out. Right, you guys learn the shortcuts, but the whole idea is we want to understand the definition. So f of 2 plus h minus f of 2 divided by h. Yeah, those shortcuts that you guys are showing me, those are actually theorems. They came from famous mathematicians that prove those shortcuts. Right, but that's not a definition of a derivative. So okay, so take a minute. So try to do this yourselves, guys. Okay, so I'll come around a little bit just to see how the algebra is going. So take a couple of minutes, come around and check.
의생이 기계에 감았을 때는
근데 같이 보려고 하시나? 그래서 시간이 또 아무 이 그런 만약에 가서 그것을
Я трудно решить, 무슨 말 이거 나 이게 나는데 내가 아까 전에 나왔고 가서 보면 생기는 просто вообще говоря, полный анализ. Уровень роста стула.
Yeah.
How we will internet.
Yeah. A lot of altitude. Neutral.
Yeah, my sarcasm over text. I didn't even expect this. Why? So like, this kind of sarcasm is enough. Because the guy was always sarcastic. Snakes and fancy stand.
So probably 2.8.
That's a good.
Plus nine, so that's.
So that when you're looking at your notes, you can remember me. No, no, no. Yeah. I'm scribble.
Everyone's in.
Like this reminds you to smile when you're suffering, so you're gonna test. I should add one for myself, to be honest. To motivate you. Exactly. A little check point, you know, oh my god, you're not so far, like when you like. Good job, I'm so proud of you. Proud of you for me. If you look at your notes, to be honest. That's like a shameful smiley face, to be honest. Yeah, everyone in seventh grade is like playing this game.
Let's put parentheses.
So cute though, I like the pictures. How long have you been doing it? Like how long have you been doing all the way to it? Like a week? Yeah, a week.
Yeah, the algebra.
A quick one right now, really fun.
Then you plug in 2+8.
한쪽
Oh, yeah.
What do you get if you plug in 2+8?
مثلا منتشر يسمعوا صوت القراءة
Now you're just gonna plug in 2.
I say times 2.
وش يخمر لازم x분의 2 플러스 2 remains x means
Then no minus three and then there's a minus before. Slash the group slash. Then sonuçta
positive means just
pozitif mi cevap?
Girl, please.
Ananı bilemem. X olarak minus x minus 9 da geldi. Altına yakın çözümde x minus 8 bu arada. Yakın olursa sonra.
무슨 해당합니다. 문화가 인제는 많이 잘했었죠.
Wait, which question is it?
Niye yapacağım?
So 4
그런데
minus 16.
문제가
4 minus 16 negative 12
Minus'ta değil.
plus
인도
16
어떻게 버스가 있어 보여?
then it becomes a positive, so you get a 12, positive 12, 4 minus 16.
하나의
It'll work.
work us problem is
You know, you'd be like, oh, she just couldn't get like, oh, like, oh no, I did that. If you really absolutely cannot answer it, just copy it back. You're like, oh no, abuse.
Plug in two. Plug in 2. I would think it'll end up being
Unnecessarily long. You know, it's like, you know, like, it's like absurd. It gets to go so crazy between our classes, like, bios.
Hey, guys, so yeah, be careful with the algebra. We plug in 2 plus h, right? Most of it is an algebra problem, so 2 plus h squared minus 8 times 2 plus h plus 9. And then minus f of 2, right? So you have to do two things in pre-calc. You have to be able to plug in 2 plus h, wherever you see an x, and you have to be able to plug in 2, wherever you see an x. So it'll be 2 squared minus 16 plus 9 divided by 2. Yeah. But you have to get used to the awfulness also, right? These are all awful algebra problems. You have to get used to the awfulness. Won't be as awful. Oh, divided by h, yeah. Yeah, I miswrote that, divided by h, okay. So remember, the algebra will be fine as long as I can cancel the h in the denominator. So 4 plus 4h plus h squared minus 16 minus 8h plus 9. And then minus, well, I have 4 minus 16, negative 12 plus 9, negative 3. So it's minus negative 3 divided by 8, right? So if you do the algebra right, so everything should cancel here, right? So I have 4 and negative 16 is negative 12, right? And then I have 9 and 3, which is plus 12. So they all cancel. Okay, so we get limit as h goes to 0. What am I left with? 4h minus 8h minus 4h plus h squared divided by h. I could factor out an h, so negative 4 plus h over h. And what does this equal to? Now I could find, after you cross, you could just plug in h equals 0. So what do we get? Negative 4. Okay. Yeah, does that make sense, guys? You see how we're doing that? So, make sure you're not messing up on the pre-calc step. You want to plug in 2 plus h correctly. Okay, and then you'll have foiling to do. Each one of these will have some algebra. Hey. All right, who messed up on the algebra? Hey. You see where you messed up now. Any questions on this? Yeah, I saw your papers. It looked good for the most part. So the only thing I saw were just the algebra things. Just be careful with that.
Right now, I like this better than. This real. The baby still is just kind of weird, it's like, nice, it's like everyone's doing it.
Okay, let's try another one. What I'm gonna do with these examples, I'll just make the examples so that you get to see the harder algebra in each of these problems that you have to do. So they'll get harder, a little bit harder and harder in algebra, and that'll give you a range of little algebra tricks to solve them. Let's do f of x is equal to radical x plus 7. Radical x plus 7. And then part A, find f prime of -3. And part B, equation of tangent line to
That is just.
graph
That is
uh,
previous, that is.
f of x at x equals -3. So watch out, most of the problems on the web assign, they'll have two parts. You'll need the f prime, which gives you the slope. That's the idea. The definition for slope and f prime are the same. F prime gives you slope, and then you'll need to write the tangent line. So for part A, f prime of -3, we're going to use the definition. What's the a value in the definition? What a value do we use? Yeah, Matthew?
-3.
-3. Right, so in this problem, I put 2 because they were asking for 2. Here, they're going to ask for -3. F of -3 plus h minus f of -3 divided by h. See how far you guys can get with the algebra. The algebra trick you need, remember, it's 0/0 with a radical. So you have to rationalize. So rationalizing is the trick that you need for this one.
Yeah.
Just like read off the tree something.
And I'll do this at 3:43 if you need a break. 3:43, I'll do this. But if you need me to check your work, just let me know. I can check your work.
Basically, very, a lot of people are struggling. They really just so for people that are not struggling.
Yeah, Matthew?
I think I did something wrong.
Oh, yeah. So this part is good. Now to rationalize, you have to constant function.
Oh, yeah, I remember now.
So just multiply by the same numerator, but with a plus, and it'll work out.
So this is what I could actually talk to. Like, now I got this next to you.
More something, yeah.
I would like to show another method of derivative. Which like, you know,
Yeah, this is the shortcut. Yeah, the
Yeah,
shortcut. So
shortcut.
this is two X minus eight.
What happens? Can we solve this problem like with?
No. So that's a shortcut. That's a shortcut. That's not the definition of the derivative. The definition of the derivative is this. These are the shortcuts that we learn later in the
but
course.
within the exams, we should use this one.
Exactly, yeah. The exam will say.
Okay, so
Once we learn the shortcuts, then the exams will let you do the shortcut.
can you
The,
explain?
the idea is that these are simple enough that we could actually compute them by hand. These shortcuts that you're talking about, we'll get way more complicated examples to do the
Okay.
shortcut.
So I have same question about range. So how can we find this range? We found domain, it was like niche,
Yeah.
but we can't find the range.
Range.
How we can find range?
So the easiest way is probably just to graph it. If you graph it, then you could just kind of read off the range. It's hard to see the range if you just have the function. You're right about the domain.
Yeah.
In terms of graphing it, you'll first of all, you have like vertical asymptotes. So like x equals 3 and -3. So actually, this domain's also not true.
Yeah.
Actually, can't be
-3
3 and
also
-3.
Yeah.
And when you graph it, and then -3, and then you would check this graph, like you'll have vertical asymptotes here.
They need help.
So like, let's say 3 from the right will be plus infinity. It'll start going like this. If x gets really large, this goes to 0. So it'll probably go to 0 like this. 3 from the left will be minus infinity. If I plug in x equals 0, I get -5/9 goes to here. And then I could also do like -3 from the right and the left. So this one will be minus infinity.
Where is cube?
I just plugged in x equals 0.
Oh,
I just plugged in x equals 0, so that helps a little bit to figure it out. And then I could do -3 from the right like this. X goes to -infinity like this. So you can use a calculator to help you, and then you'll get something like, then you could read off the range. So the range would be -infinity to -5/9. And then there's nothing here really, and then 0 to infinity. So that-
This is the one. Oh. It's very awesome.
Okay, so each of these are they're gonna involve an algebra trick. What happens if we plug in -3 plus h?
Was that easy to take off?
Limit as h goes to 0. If I plug in -3 plus h, what should I write? What will I get? Radical what?
-3.
3 plus h in parentheses and then plus 7.
Good, -3 plus h plus 7, it's all under the radical, good. Minus, then what do I write?
Radical -3 plus 7.
-3 plus 7, all divided by h.
no,
Good. Limit as h goes to 0, so I get radical 4 plus h minus radical 4, which is 2, divided by h. Okay. Now, it's a 0 over 0 limit, but with the radicals. What was our trick? What do? We rationalize, right? We multiply by the radical piece, but with a plus sign. So we have to do top and bottom. Radical 4 plus h plus 2.
Tamam mı?
Radical 4 plus h plus 2. Like that. Is equal to limit as h goes to 0. Okay, so when we rationalize, the numerator becomes 4 plus h. And then minus 2 times 2 minus 4. I recommend when you guys do this, don't distribute the denominator. Don't do like algebra to the denominator. Keep the denominator as is to get it ready for canceling. So I won't distribute the h. And look what happens, 4 minus 4, right? Limit as h goes to 0. We get h divided by h times radical 4 plus h plus 2. Okay, the h's cancel. So we get the limit as h goes to 0 of 1 divided by radical 4 plus h plus 2. And now we could just substitute h equals 0. So 1 over radical 4 plus 2. So 1/4. Okay, so 1/4. You guys get that? Okay. Okay, any questions on this, guys? So remember, all the tricks that we need to do this came from the previous sections. That's really why we did the rest of chapter 2, so that you're able to use all those tricks to compute these limits. That's what you need. Yeah. No.
2.1.
What is it?
This is still 2.1.
So this is 2.7.
Yeah, I was about to ask.
Yeah, it's 2.7. It's section 2.7. But 2.1 and 2.7 go together because the slope of the tangent line, the derivative, it's the same definition.
Why did they do it like that?
Why do they do it like that? Good question. I wouldn't do it like that.
You could make a textbook then.
Yeah, I put 2.1 and 2.7 together. I think 2.1 is too hard,
It's not close.
you know, if you haven't learned limits. So they really go together. Okay, good. Questions on this? Yeah. Okay, that's only part A. Now, part B, pay attention to the question. They're either going to want a tangent line or a slope or both. So make sure you give them what they ask for. If they ask for tangent line, don't put down a slope. Okay, if they ask you for a slope, don't put down a tangent line. You have to know which one. So just remember, the derivative is the exact same definition as the slope. So I'll even put m here just to emphasize it. They are the same. It's giving you the slope, right? The f prime is giving you a number, which is giving you the slope. Okay, so part B. We have a point P. The point P, they always have to give you, it's -3, comma, what's the y value of the point? Right, I have to plug in -3 for x. -3 plus 7 is 4, and then radical 2. And what's the slope?
1/4.
1/4. Okay, so remember, guys, don't get thrown off. Don't be like, oh, I computed the derivative. Where do I get the slope? No, the derivative is the slope. Is the slope, right? Same definition. Okay. That's why we put 2.1 and 2.7 sections together. So you see it's the same definition. Okay, so it's y minus 2 is equal to the slope times x minus -3. And that's it. Okay. So at that point, you don't have to actually do any work. You just have to put the pieces together into the tangent line. Yeah, question on this. And what does this look like? I guess pictures are fun. Yeah, pictures fun. Pictures are fun. So -7. Here's the graph. Okay. So at -3, -3, the y value is 4. So I have this point, and what did I compute? What's this line? How do I draw this line? Is I have a graph, and I draw the tangent line. Right, and that's this line. So here's f of x. And that's this line that we just computed. Okay. It'll be a while before we actually use this line, but this line helps approximate the function. Okay, and this line has a slope of 1/4. That's the idea. Now, notice that this is just one line. Okay, this is just one line at -3. But they could ask you for, any other point and make a tangent line for any other point. And any value a, we can get a tangent line to the graph at any value a. So it really doesn't matter. So if they ask you, and I think one of the WebAssign questions is like this, it's still the same function, but let's say part C, compute f prime of a for any a, any a. I guess the a has to make sense, so it has to be in the domain here. So a is greater than -7. Okay, but they're asking you for the slope at any value a. So the algebra is the same, except everything that we did here, instead of -3 being our point, we'll just keep it general at a. That way we can get the slope at any single a. Similar to velocity, if f represented position, then this would tell us the velocity. So we can get the velocity at any time, not just at one time. We can get the speed, the velocity of the car at any time a. So what do you guys have to do for that? Right, so it's still this function. We're still using this. So f prime of a, just you don't plug in -3 when you do this. Okay, so f of a plus h minus f of a divided by h. Okay. So in the last example, a was -3. Well, let's just mimic, we'll just regurgitate all the algebra without plugging in the number -3. Limit as h goes to 0. So let's plug in a plus h. So what should I write? In terms of pre-calc, if I plug in a plus h for x, what should I write? What would be the pre-calc answer for plugging in a plus h? Yeah. That's Sanjita. Right, square root of a plus h plus 7. Do you guys see that? Yeah, the h is not on the outside. It's x is any input. I can put in any input. A plus h is an input. Right, it's one input. A plus h. And what do I write for f of a? What happens if I plug in a, Lisa? Radical a plus 7. Okay, do you guys see that? So it's very similar as having a being -3, but I just have to keep it as a. Keep it as little a. Take a minute, see if you could do the algebra. It's the same algebra. I just rationalize. Just top and bottom with the plus. Do top and bottom with the plus and see if you could simplify it. I wrote down your first step, but if you guys could do the algebra there.
Have something like this now coming up test.
You'll have one problem on derivative like this, yeah. I put up a practice, so it'll be same length. Put up a practice. Yeah. Yeah, Jackie.
Backtrack a little bit.
What is it?
And then +7.
Square roots on this part? Yeah, so the function is x plus 7.
Oh, that's the function.
Yeah, it's still the same function from before. Yeah, this is the function. It's the one that we did for f prime -3. It's the same function. So I'm just plugging in a plus h into the function, a plus h into the function.
Sorry.
Yeah.
Okay, thank you.
Yeah, so we're keeping the function the same. Yeah, that's our function. Yeah, good. So what Jackie's asking, this is like, let's say part C of the question. Here's our function. Now they want the slope at A. Slope of the graph at A. So limit as h goes to 0. Okay, so we're just going to FOIL this out. So radical times radical, a plus h plus 7. Right, the plus and minus radicals cancel, and then minus, what's radical a plus 7 times radical a plus 7? A plus 7, just put parentheses or you're doomed. Really doomed. It won't cancel if you don't put parentheses. They'll all get messed over. You need the parentheses. Okay. Be careful with that. Divided by h times radical a plus h plus 7 plus radical a plus 7. Okay, what can I cancel in the numerator? A cancels. What else cancels? 7. What am I left with?
H.
H.
You cancel that with a.
And I can cancel h with the denominator. Right? What am I left with? I have very little left. I'm left with 1 divided by radical a plus h plus 7 plus radical a plus 7. After I do the cancellation, I could just substitute h equals 0, right? A is staying at a, it's h equals 0. So 1 divided by 2 radical a plus 7. What is it? The two? Yeah, it's radical a plus 7 and then plus radical a plus 7. So I just combine them, two radical.
Just leave it like that.
But yeah, so that's good. You could write a radical a plus 7 plus. See, I plugged in 0 for h. I'll even emphasize it. So a plus 0 plus 7 plus radical a plus 7. You could leave it like that if you want. Keep it unsimplified. So that's the slope. That's the slope at any value a. So if they're asking you the slope of the graph a equals 5. So here's the advantage. Now, this is f prime of a. This is the slope at any value a. So what if I ask you f prime of 5? Now, I just got the answer for any a. What's f prime of 5?
Plug in 5 instead of 8.
Right, just plug in 5 instead of a. Right, I got the slope for every number that there is. I got every slope. Right, I got every slope. So f prime of 5 is 2 radical 5 plus 7. I got every slope. Yeah, so I could use it. Right. Is there a question? Are there too many slashes there? Is that confusing people? Slashes. Hey, Josiah, you had a question. Oh, where did the 2 come from? Yeah, I just combined them, but really here I circled this one, so this is fine, even without simplifying. That's fine. Plug in h equals it. Yeah, so make sure you could do like this. This is one of the more, I guess, one of the more basic ones. Make sure you could do something like this for the exam. So it'll be one derivative question. Okay, good. Other questions on this? Are you guys okay with the algebra?
Yeah.
Okay, so this is what you'll do for the radicals. Okay, so let me give you another example so you see which algebra tricks you need. Here's another example. F of x is equal to 7 over x plus 4. Tangent line at 6 comma 7 tenths. Okay, so they want you to get the tangent line at 6 comma 7 tenths.
I don't think we even have that.
So every tangent line, right, we need the slope. And the slope is the derivative. But which number do we need? What's the a value? 6. Okay, so you're always going to start with this. F of 6 plus h minus f of 6 divided by h. Okay, so let me give you guys a minute. See if you could do this one. At least plug in 6 plus h. Then plug in 6. See if you can figure out the algebra for one. Because you're dealing with fractions, our trick is combining fractions. So see if you could figure out a way to combine all the fractions.
But you know, I'm not there's a button.
Okay, if I plug in 6 plus h, what do I get? What do I get when I plug in 6 plus h?
7/10 plus h.
7 over 10 plus h. Okay, want to be able to do that just basic pre-calc. If I plug in 6 here, what do I get? 7 over 10 divided by h. Like that. Okay, two fractions. So what's our trick? We need a common denominator to combine them. What's the common denominator here? Yeah, Matthew?
Plus h.
10 plus h. So this one has a 10 plus h, but this one doesn't. So it won't be in common. This one has a 10, but this one doesn't. So what do we need? What will make it common?
Yeah.
10 times 10 times 10 plus h, right? That's how we combine fractions. Yeah. Matthew, this 10? Oh, this 10 or this 10?
The first time.
The first 10? So I plugged in 6 plus h for x, and then 6 plus 4 combined to make a 10. Yeah, so f of 6 plus h is 7 divided by 6 plus h plus 4. Is that what you were asking? And then the 6 and the 4 combined to make a 10. Yeah. That's the first step. Okay, should we color code this one?
Yeah.
We color code the algebra. All right. Red, green, or blue? Red. Okay. Common denominator. Here it is. Cameras out. All right. Oh, okay. No, I thought you were just really curious. How do we get? We'll get excited about common denominators. That's cool. Okay. All right. Let's do it. So times 10 over 10 for this one. And let's do another color one. 10 plus h. 10 plus h for this one, right? That'll put them in common. That'll make the denominators the same. I'll make them the same. All right, which color do we do now? Black. Go back to black. Yeah. Limit as h goes to 0. Okay, so the common denominator is 10 times 10 plus h. Okay, and now we could combine the numerators. So I have 7 times 10 here, which is 70, and then minus 7 times 10 plus h, all divided by h. Could already see a cancellation. I'm very close to cancellation. What will I be able to cancel? Yeah, notice the 70 here. I have a 70 here, and I'll get a minus 70 here. Limit as h goes to 0. 7 minus 70 is 0. So I get a negative h divided by 10 times 10 plus h divided by h. What is it? Negative 7h. Oh, that's right. Good. Yeah, what Jonathan is saying, distribute the negative 7. Negative 7h. Okay, fraction over a fraction. How do I simplify that? So you have Ronaldo? Yeah, Ronaldo?
The top part,
Yeah, so negative 7h is the numerator. What's the denominator?
100 plus 10h.
100 plus 10h. Yeah, I don't need to simplify it, but I guess I could. I'll just keep it as 10 times 10 plus h.
You multiply it by h over 1.
H over 1, which is just h. There. That h is in the denominator. That's it. So fraction over a fraction. I can make it one fraction. Right? H's cancel. H's cancel. And then h goes to 0. So what will I have left?
Negative 7 over 100.
Right? Negative 7 divided by 10 times 10 plus 0. Right? Negative 7 over 100. That's the slope. Okay, any questions on, yeah, Matthew?
How did you go from there to there?
Which line? This line? Oh, this line?
There
To
to there,
this?
yeah.
Yeah, so, right, this cool algebra rule, A over B divided by C over D. I could always take two fractions and combine them into one. Is AD divided by BC, right? Algebra rule. Yeah, so here, C over D is the same thing as H over 1. So I have a fraction there.
Oh, I see.
Algebra rule. Okay. Division by two fractions. Okay. Did I actually answer the question? Web assigned market right? No, what did I do?
The slope form.
Hmm? Did they ask me for the slope? No, they asked me for the tangent line. Yeah, so here, in order to get it right, you actually have to write the tangent line. So y minus 7/10 is equal to negative 7 over 100 times x minus 6. Like that.
That's all.
Okay, question on this. Yeah. Okay. Any questions on this? Yeah, John.
The negative 7 over 10, where does it come from?
Negative 7 over 10. Oh, so the tangent line is at this point. So the point is 6 7/10. So the y value is 7/10. X value is 6. Yeah. So they'll give you the point. Either they'll give it to you in this form, 6 7/10, or they'll just tell you at 6. So you'll get the 7/10 on your own. You could just plug in x equals 6. Then you'll get the 7/10. Yeah, so they have to give you the point that they're looking for. Okay, the point that they're asking you about. Okay. All right, ready for a hard one? Hard one? All right. It's not hard because it's conceptually hard. It's just harder because of the algebra. The algebra keeps getting worse and worse. Keeps getting worse and worse. So this one has pretty bad algebra. 1 over radical x plus 1. Yeah. Okay, f prime of 2. Say they're asking for f prime of 2. Okay. We always start with the same formula. F of 2 plus h minus f of 2 divided by h. Limit as h goes to 0. If I plug in 2 plus h, what do I get? Right, 1 over radical 2 plus h plus 1 minus what? Right, 1 over radical 2 plus 1. Right, as rad 3 divided by h. Okay, so I'll even write it as 1 over radical 3 plus h minus 1 over radical 3 divided by h. Okay. First thing, you'll have to combine the fractions like last time to get a common denominator. Okay, so try that. See how far you can get. Try to figure out the common denominator for these two fractions. But then afterwards, you'll have to rationalize. Okay.
Oh my god. Mas
Please do it.
Bugün nasıl olmuş?
Okay, notice guys, the common denominator is rad 3 times rad 3 plus h. Okay, that'll make the denominator common. Let's limit as h goes to 0. Okay, so the numerator is rad 3 minus radical 3 plus h. And what's the common denominator? Rad 3 plus h times rad 3, all divided by h. I could do the same thing as before. So this is limit as h goes to 0. I could combine fractions with the h. So I can put the h there. Rad 3 minus radical 3 plus h divided by h rad 3 radical 3 plus h. So that's what, that's where I get up to just combining fractions. What's the next step? How do I simplify this? How do I go further? I can't cancel anything yet, unless you do that crazy thing where you're like, oh, rad 3 plus h there and rad 3 plus h there. Let's just cross them out. Right, rationalize it. Right, we have to rationalize. Right, we can't do that craziness. Okay. How do we rationalize? Top and bottom by what?
Multiply for root.
What should I multiply top and bottom for? Another color.
Radical 3 plus radical 3 plus
Right,
h.
radical 3 with a plus. Right, this is with the radical, with the minus. So I'll do it with a plus. Radical 3 plus radical
H.
3 plus h. And then radical 3 plus radical 3 plus h. So then the limit is h goes to 0. Should I give you guys a minute to see if you can work that one out? Yeah. If you could FOIL that one.
It's not, maybe you're just like confused with how it is. That's probably. Yep. Me through it, I don't feel like we can. It's just wrong. You can't create wrong.
Üstü bırak. Bir aşağı.
Okay. Rad 3 times rad 3 is 3. Plus and minus radicals cancel. Rad 3 plus h and rad 3 plus h is regular 3 plus h, but I put parentheses. I wouldn't dare forget the parentheses. Then we'll mess the whole thing up. We're doomed. All that work will be for naught if we forget the parentheses. It won't work. Okay. So we have h times rad 3 plus h. Little tip, When you do this, do not simplify the other piece. It'll mess you over. Right, so don't simplify it, leave it like that. The threes cancel, right? What's the numerator left with? Just negative h. What does that cancel with?
The ages on the.
H on the bottom.
One.
The h will cancel, right? Because the threes cancel. All I'm left with is limit as h goes to 0. -1 over rad 3 plus h, rad 3 plus radical 3 plus h. Limit, no more limits. Because once I have the cancellation, I could just plug in h equals 0. -1 over rad 3, rad 3, rad 3, and rad 3.
Radical.
Okay.
Simplifies to -1 over 6 radical 3, right?
Yeah, it does simplify, yeah. Let's see, 2, 3 times, yeah. 6 radical 3. See, Matthew?
So are you gonna put this on the test?
Yeah, so remember, anything that where it's like, oh, that's hard because of algebra is fair game, right? If it's hard because conceptually it's hard, then those WebAssign problems usually don't get put on the test. But if it's only because it's algebra, yeah, those are for sure. Yeah. Those are for sure fair game, yeah.
Explain why h is next to the radical 3 once you like.
Oh, let's see. This line?
The one on top. Like with the red stuff.
Oh, with the red stuff here?
Not that. No, like the step after it. Yeah.
This step?
Why is it like, why does h go to?
Why does H go over here? Yeah, so same idea. It's so A over B, C over D
Oh, never mind.
is AD over BC.
Never mind.
Yeah. It's that fractional thing, yeah.
Yeah. Be embarrassed to understand.
Yeah, decide. Cancel which part over here? That line? Do you see how the 3 and the 3's cancel? Yeah, see, it's 3 minus 3. So what I'm left with in this line right here is I'm just left with negative h in that line. Because the 3's cancel, so then the minus just gives me a negative h. But the h will cancel with the denominator. So I have my denominator here. And those cancel. Yeah, do you see that? Yeah, so it's just more algebra, but you'll see the WebAssign will have these.
No, that, to be honest.
Okay, question on this. Yes, do you guys see it? There's really not much other variation. It'll be fractions where you have to combine fractions. Or you'll have to factor, if you could factor, or you'll have to rationalize. So it'll just be one of those 3 algebra techniques. Yes, Raphael?
You make the test.
Yeah, the tests I do, not the final, but I make the tests. Yeah, I put up a practice test. Now, the practice test is not just a practice, it was a real exam, like in 2019. Right, the students had. So if you go in the handouts module, it's there. So it has a practice exam and it has solutions. So it'll give you a pretty good idea of like the length and the difficulty. But I just get the questions from the WebAssign. So just things on the WebAssign are fair game. And then like the hardest WebAssigns are not going to be on there, but the intermediate and versions are intermediate questions are on there. Okay, any questions on this example? Okay, questions on this example? Yeah, Ronaldo. Yeah, was there a question? If is your point, you want to come point? Yeah, what is it? Just an evil example.
I'd say it's. But if there were to be like another set, like a fraction on the bottom with x, right?
Yeah,
Obviously you would have to put it with the plus h, but would the denominator of the h still be under all of that? Or-
under all of that, yes, under all of it. Yeah, under all of it, yeah. Yeah, so in this piece, whatever function they give you, whatever crazy thing they give you, you'll plug in 2 plus h. That'll be in the numerator. Whatever crazy thing they give you, you'll plug in 2.
So
That'll all be in the numerator, and the denominator at the end will always be at the bottom. Yeah, so h will always be in the denominator. It never switches to the numerator. It's not, something else won't go into the denominator. It's just the h. Just the h. Okay, conceptual thing in this section. Okay, so the derivative as a rate of change. Okay, so this is a conceptual thing that you guys need to know for this section. Right, we saw how the slope of a curve is kind of giving us the rate of change of the curve, how fast the curve is increasing, how fast the curve is decreasing. Okay, so we could do that just for any function now. Okay, so we have f of x. So we have the point P at, let's say, a comma f of a. Value a and the y value. Okay. So if we have a point Q, which is a plus h, f of a plus h. Right, and we make a secant line again from point P to Q. So the secant slope MPQ of this line, right? The secant slope of this line. Should I make it in green? Maybe let's make it in green. Let's color code this line with green. So I'll make the secant slope green. Okay, change in y over change in x. Right, so it's f of, right, if I do change in y and change in x for these 2 points, f of a plus h minus f of a. Right, so just like we saw with velocity, if f is not position, it's just a regular function, then this is just the average rate of change of f on the interval a plus h. Okay, so the secant slope will give us the average rate of change. On average, how much did the function change from a to a plus h? Right. And then in red, I'll make the tangent line. Right, so the slope of the tangent line, that's f prime of a. So that's the instantaneous rate of change, instantaneous. Right, similar to instantaneous velocity for any random function, this is instantaneous rate of change of f of x with respect to x at a. Right, so the derivative is the instantaneous rate of change, similar to instantaneous velocity. It's how fast whatever the function you're dealing with is changing at that moment. How fast it's growing or how fast it's decaying. So just as an example, yeah, so let's see. Let's write it like this. That. Right. If I look at this point, right, and this is our function f of x. Is the rate of change positive or negative? Right, what's the slope? Positive or negative slope? Right, positive. Right, that means that the function is increasing. So the way we would say it is f prime. So over there, f prime, the slope of this graph is large. Right, the slope of this graph is large. And over here, right, first of all, is the slope positive or negative? Positive, right? Smaller or larger than the previous slope? Right, this one is this one is smaller or larger slope? Right, smaller slope. Yeah, so it has a smaller rate of change. So f prime is it's positive rate of change is smaller. Okay. You could also say that increasing more slowly. Okay. Right, so we have a positive slope. That means that the rate of change, the function's increasing, but it's slower over here. The increase is slower over here for, let's say it's measuring stock value, and the increase is higher over here for measuring stock value at a certain time. If this is also part of our function, right, what would this slope be? If I make a tangent line, what would be the slope? Positive or negative? Right, negative, which means that the function is decreasing. So here's the slope of a tangent line. Here, f prime decreasing. So it's a negative rate of change. So another way to say this is that f prime of a, what is it? It's the rate of change where you're looking at delta y divided by delta x, and you're pretty much taking the limit as delta x going to 0. Right? Is you're looking at this sort of average rate of change, which is the slope of the secant, and you're letting delta x go to 0 to get the instantaneous rate of change. And it will be equal to, it will be approximately the average if delta x is small. Question?
This tends to zero, then isn't it infinite limit?
Oh, but delta y is also changing to 0. See, it's still 0 over 0. See, delta x is like h. But delta y is also tending to 0.
Yeah.
So it is 0 over 0. We don't know what'll happen. As we saw in all those examples, we do get a number out of it. Yeah. So it's basically what a derivative is. It's the rate of change. If we take the average rate of change from a to a plus h, and we let h go to 0, that gives us the instantaneous. But it's 0 over 0. Okay. How do you describe it in words? What's f prime of a in words? Okay, in terms of a rate of change, what is it? What is a derivative really telling you? So roughly, if x increases from a to a plus 1,
Yes.
then f of a, then f of x will increase, decrease, whichever one, depending on positive or negative, by f prime of a. Okay, so f prime of a is describing how much the function will change. So if we move from a to a plus 1, how much will the y values change when we go from x equals a to x equals a plus 1? Right, and they're going to change by f prime of a, whatever the slope is. That's what it's roughly telling you, right? It's telling you how much the function is going to change. So like if, let's say f prime of a is 5, so that means as x goes from a to a plus 1, f will jump by 5. Okay. That's how much the y values are going to change between two x values. Let me do a more concrete example, just so you see what this looks like. Right, so a manufacturer produces bolts of fabric, and the cost of X yards of fabric is f of x dollars, right? That's going to be the cost of the for the manufacturer. Okay, so let's see what the derivative is telling us. What is f prime of x meaning in this context? Okay, well, it's delta y over delta x, right? So f is being measured in dollars, right? So what is it telling you? It's the instantaneous rate of change of production costs with respect to number of yards produced. Okay. So the units, right? How do we get the units? Well, it's delta f, the y values divided by delta X, well, the numerator is measured in what? In dollars. And the denominator is measured in what? The X's are measured in yard, so it's dollars per yard. Okay, so what would the derivative tell you? Is that it's telling you the marginal cost in economics. F prime of X is marginal cost for an additional yard. Right, so it's telling you how much more will it cost if I want to do one additional yard, let's say. That's what it's telling you. So it's rate of change. Right, so let's say I'm producing 5 yards. If I want to go from 5 to 6 yards, how much will my cost increase? My cost increase is F prime of X. Right, that's what the derivative is telling you. It's the rate of change. Okay, so how much more cost will it be to get that additional yard? So as an example, interpret F prime of 1,000 is equal to 9. Right, so this is dollars per yard. Okay, so what does that mean? At 1,000 yards of fabric production, the cost will increase by $9 for each additional yard. Right. So the rate of change is 9 at 1,000. That means that when we're producing 1,000, if we want to go from 1,000 to 1,001, the derivative is telling us it's about $9 more. Right. So the rate of change, $9 more. Okay. And that could change depending on the number of yards that we're producing. Any questions on that? So that's what it's telling us, derivative as a, oh, Layla?
So I don't think I understand. So at 1,000 yards, does it mean it costs $9 per yard to produce at 1,000 yards?
Exactly, that's right. $9 per yard. So that means I have a certain cost for 1,000 yards, whatever it is. If I want to get an extra yard of production, $9 per yard at that point.
$9,000 in this case to produce 1,000 yards if you want 1,000 yards?
Not necessarily. The function could be very complicated for a manufacturer. So 1,000 yards might cost them, I don't know, $5,956. But at that point, once he reaches that point of 1,000 yards of fabric production, if he wants to get more yards, start producing more yards, it'll be $9 more for each one. That doesn't mean it costs $9 for the 1,000, because you could like buy in bulk. So, you know, the first yard could start costing like, the first yard could be $50. You know, then the manufacturer could be nice. Oh, you do 2 yards. The second yard, I'll do 40. You know, the third yard, I'll do 30. And once you get to 1,000, you know, he told you whatever that cost is going to be. You know, it could be a very complicated function. But the derivative is 9 is at that point, he'll start charging you $9. So maybe he started charging you at, let's say $15. Once you get to that bulk of 1,000, the marginal cost is 9. So at that point, it'll be 9. Okay, good question. Yeah. Yeah. Does that clarify it a little bit? Yeah. So it's 9. It's not $9 for each of the 1,000. It's $9 is gonna be the rate of change when you go past 1,000. That's what it's telling you. Okay, we'll pause here, guys. The homework is up, so you could look at the homework for this section. Okay, this is at 2.7. Any questions? I'll stay here for a little bit.